So now that we've talked about the pros of the Completable Futures framework, let's switch over and talk about the cons. And as always, as I always say, everything is not going to be rainbows and unicorns. So we have to be very straightforward about some of the downsides to using these technologies. As before, we'll use the parallel streams framework as a touch point to compare and contrast the different alternatives. So first and foremost, it's easier to program parallel streams in general than it is to program completable futures. And comparing these two programs side by side helps to clarify and codify why that is. Now, the overall flow of control is very similar because we're using Java streams for both of them. But on the left-hand side, we're using parallel streams. On the right-hand side, you're using sequential streams with asynchronous processing. And you can see there are just more steps, and each of the steps is more complicated. And the reason why this is the case is because the Completable Futures version is doing asynchronous processing. So we have all the stuff we've got to deal with things like collect and then supply async and supply, then apply async and supply async and all this good stuff. So there's just more things going on there that have to be thought through. So in general, and this is not just the case for Java, this is just true in general, there's almost always a trade-off in computer programming between programming productivity on one hand and computer performance on the other. As a general rule of thumb, not always the case, but it's usually the case that the easier something is to program, the less efficiently it's going to run. Now, there's lots of exceptions to that, but that's a common trade-off. So as a general rule here, completable futures are more efficient and more scalable, but they're a bit harder to program. So if performance is more important than productivity, then completable futures is the way to go. And why this is the case, why it's harder, is because people typically just don't have as much intuition developed for asynchronous programming and the patterns and idioms therein as they do for synchronous programming. Most of us started out with synchronous programming. That's just a very natural thing to do with two-way method call semantics, and asynchronous stuff is just a bit weirder. Conversely, parallel streams are easier to program because they're synchronous, but they tend to be a bit less efficient and a bit less scalable. Again, typically way better than doing things sequentially, but not as good as using completable futures. Now, what makes this also nice for parallel streams is you can quickly get your program working sequentially, debug it, and then usually just make a minuscule change to go from stream to parallel stream, and boom, all of a sudden you got this big speed up with little or no effort to your program. So that's a good benefit of that approach. So as usual, this is the case always, you always have to understand the patterns, you have to understand the best practices needed in order to be able to program any framework effectively. And that also, of course, applies for completable futures. You've got to figure out how to program them. And hopefully these examples we've walked through will give you a better intuition on how to do this in practice.